In this Mathematica Sessions video, what I'll be doing is teaching an absolute beginner who is studying microeconomics, and this person wants to be able to enhance his studies using Mathematica. And so this is roughly an hour-long session in which I'm teaching him from an absolutely elementary level and bringing him up so that he can build some plots and calculate some things and become better at his understanding of the topic. So if you're interested in that, then stick around. So you're studying econ, right?
Yeah, I'm studying economics, and
Right.
a lot of economic analysis is mathematical analysis, particularly
right.
calculus.
Yep.
So
yeah, there's a lot involved in that. So supply and demand. I studied a little bit myself, so I'm kind of a little bit familiar with that stuff. So I've got your thing here. So shall we just start talking about that?
yeah, sure.
Are you ready for me to screen share with you?
Yeah, I will. Yeah.
Or
can you see my screen? No.
Not yet, but why don't you try to screen share?
Okay then.
Have you?
Okay, I'll let you take control.
No, you.
I think you can see a bit.
Oh, awesome. Yeah, works perfectly. Yep. So you've got the definition of the derivative there, basically.
Yeah.
Yeah, that's great.
I'll just bring it up.
Okay. Yep, that's good. That's the one I've got on my desktop.
Yeah. What I'd like to do is I would like to plot this. So I've plotted this on Mathematica.
Yep.
I think. What's
all right. So comment, right? This is how you make a comment. So I'll just write your name is how I spell your name, and this is the 2nd 11/2020. All right. So this is how I typically do it. I'll write things in comment. So you wanted to plot this. So you got b to the power of x. And I guess you're plotting it in terms of x, right? So you might take x from, say, 0 to 5.
All right, so I got a problem.
But you need a value for b, right? What's up? So you need a value for b, right? Now, if we're going to plot 2 to the power of x, it would be something like this. So I put a semicolon there to suppress the 2.0. Right, and so we get this exponential curve here. Now, did you do something like that?
Okay. Sharing of the screen.
Okay, great.
My first question is basically I've drawn this, and I wanted to, manipulate the 2x, for example. When you create a manipulate command, there's got this bar that you can scroll, and I wanted to see how this changes, maybe with the domain.
Okay.
I was just wondering if we could do that, or if we could change it to. I'm not sure what to do first.
Yeah, so I think if I understand your question, when you change that to, say, a bigger number, when you change 2 to a slightly bigger number, you get a steeper curve. Yeah. So what I suggest to you to do is on the left of the 2 that you have there, put a curly bracket, like the set notation bracket.
This?
Yeah, that's right. And then end it on the other side of the 2 or the comma. You know, go left, sorry, go right again. Yeah, there you go. Put a comma. Yeah, as in another comma. And then now you want the other bracket now, the curly bracket. And then comma. Okay, and now before the purple comma, sorry, on the other side of the purple comma, put 3 to the power of x. There you go. Okay, so now you see, so the orange one's the steeper one, right? So that's the power of 3. Of course, you could do this with a manipulate tool, but I mean, this sort of demonstrates what's going on.
Yeah, okay.
So if you were to change that 3 to something else, or include, you know, more in that, inside that curly bracket there, you'd get more plots. Now you don't want to take the number 3 too high, because then it'll be very steep compared with the blue one. Right? So does that help that question, or are you not satisfied yet?
Yeah, that's fine. I can see. That's okay.
Okay.
All
right.
That's question 1 complete then. What about
if you're happy with that? I mean, you can put in something. You can put in something like 2.01 and see if there's any noticeable difference, rather than the 3. Right? You can change the 3 to 2.01.
Okay, maybe I can.
Because that's really close. And now you can just put, you know, let's see, where is this on my keyboard? It's above the 6, so that you don't have to press the buttons on the palette.
Okay, yeah, that, sure, yep. Yep, I got it.
Right, so now you've got 3 curves there. Yeah, that's right. So that's a little bit faster than hunting for the palette button.
Okay, thank you.
So the 2.01, that's extremely close to the original one, you see. So, all right, so good. I guess that answers that question. Now let's have a look at your next one. You want to manipulate. Okay, yes, we've done that. Next one, plot 1 plus 1 over m to the power of m, and manipulate m by increasing it. So I put a round bracket to the power of m, and then inside that I'll put 1 plus 1 over m, and then I'll plot this. I guess this is plotting over m, isn't it? As m goes from, say, 1 to 10. All right, so you showed something like that, right? I think I saw that on yours. Now you want to manipulate it, manipulate m by increasing m. So, well, see, this is the point for a particular m value, right? As you increase m, you get a point on this curve, right? Now, another point of view to look at in this is if we were to just say table, right? So we take this here, and instead of plotting, let's just tabulate it. I'll just copy and paste this. All right, and so now you'll see you get some numbers, right? So they're all rational numbers, but they're numbers that are points on this thing here, right? And actually what I think that we should do, maybe take a numerical value for that. Okay, so now we've turned those into decimal numbers. You still with me, Socheat?
Yeah, I'm here. Thank you.
Okay. So you see, I've just put an N around that, uppercase N, and that's just turning these into decimal numbers.
Yeah.
Now around this, I'm going to put, I'm going to make a list of points. Okay. So I'll put M comma number, and then I'll show you the output there. Now I've got a list of points where the first coordinate is the number M, and the second coordinate is these numbers. Okay, and the reason I want to do that is because I want to show you how to combine these. All right, so I'll call this one A, putting it in memory there. All right, and then underneath that, let's just write list plot A, and then I'll put in an option, plot style. Plot style, did I write it right? Point size. Something's wrong with that, I think.
Yep.
So I'll get rid of that. Okay, so you can see these as points now, right? And it kind of looks similar like that. But what we can do here is I'll call this B, and then let's call this F. I'll suppress the output on both, and then I'll say show the two of them together, as in B and F. Okay, so now what you get are those points on top of the curve. See that?
Yep. Yep.
You want to try this yourself? What I'll do is I'll copy and paste this into the chat. I'll open up the chat, I'll paste it there, and see if you can use that. And I'll stop sharing while I have a look at yours. Do you get that in the chat now?
Yep. Yep. I'm trying to do it now.
All right, so you should be able to pretty much copy and paste that into your notebook. All right, yeah, that looks good.
Yep.
Now what you can also do is you can put up there where the first line where it says table, after the 10, you could put another comma and put comma 0.5, for example, and it'll space them out in steps of 0.5.
Thank you. Thank you.
There you go. Yep. Right. So what I want to emphasize here is that when you're plotting this, you're plotting a collection of points, you see, and the closer they are together, the more it fills in that curve. Does that make sense?
Yeah, that looks interesting. Yes. Thank you.
All right. So now, now below this, you say, for example, increase M equals 1, M equals 10, M equals 100, M equals 1,000. But what you do when you do that is you get a single number, you see. But the interesting thing is that number has a limit. There's an upper bound on that number, if I remember right.
Yeah.
So I want to share my screen with you again, and I'll just play around with that some more if you don't mind.
No problems.
Okay.
Go ahead. Yes.
All right. So let's take this out to 100. I'll just change this endpoint. Actually, I'll need to suppress this part now because it's too many numbers. But so here we see now, from memory, I know that there's an upper bound on this formula here, right?
Yeah,
so
yeah.
as you increase the M, there's an upper bound, and that upper bound is the number E. So in other words, have you heard of the number E?
Yeah, that's it. It's 2.718, and then it goes on.
There you go. Yeah. So in here we can just write exp1. And in fact, if you want to take 100 decimal places of this, you could.
Yeah.
Right. Hang on. I think I have to do this. Yeah, there we go. So there's 100 decimal places of E, but if we just incorporate this into the graph here, and I'll share this stuff with you in a moment. So let's say I'll call this a number, and I'll just put double E because everything else is protected, right? And so I'll say plot this double E. X goes from 1 to 100 again, and we'll call this G. This will just be a horizontal line. So the line y equals E, for example, and then we'll show that there with the rest of it. Okay, so hang on. What's going on here? I'll show this. Okay, that's there. Now, why didn't those combine properly? I think what I need to do is go plot range all. There we go. Okay, so I can suppress this one now. Bring this back. And there you get the upper bound on it, right?
Yep, yep.
Do you see my screen where you see that upper bound is that's the number E? Yeah. You can even change the color of it, but
yeah, that's fine.
I think I don't want to give you too much programming stuff when you're just starting out with this, right? I don't want to overwhelm you. So I'll copy that and I'll give that to you.
Thank you.
So you can copy and paste that in and have a go with that one yourself.
Yeah, that's good. Thank you very much for that.
Yeah. And so like you can manipulate certain things within that piece of code there. Like if you didn't want to take it out to 100, you could go shorter. You could put less points in or more points in, just by changing little things in the code. So you probably want to play around with that if you're new to this software language. So yeah.
Thank you.
And now if, for example, if this were an assignment, you could just export it as a JPEG, for example, and embed it into your assignment.
Yeah.
So to do that, let me see if I can do that on my screen.
Yeah, I found it.
Okay, awesome. Is it in something like a document folder? Yeah, it's not exactly in the document. It's somewhere, but I just did a search of the computer and I found it. Yeah. Yeah. So there's a default where it ends up when you export things. And so that would be the same folder when you import things. So for example, you could import a spreadsheet and then use the data in Mathematica.
Okay. Okay.
All right. So are you ready for your next question?
Sure. Sure. So this is basically
all right. So your next question. Yeah.
Conceptual question. Like an understanding question for me. What I wanted to understand is that I wrote log of x divided by square root of y, and then it's to the base e. Now, I haven't written this down, but maybe I can talk to you by voice. 2 to the
go for it.
2 to the power of 3 equals 8. So log
That's right.
log of 8, the logarithm of 8 to the base 2 equals 3.
Yep.
That 3 is
Yeah.
a number. But
Yes.
now we go back to my question 3. What is this x divided by square root of y? I just spoke to a friend yesterday, and he said this is also a number, but we don't have the values of x and y. What are your thoughts about it?
Yeah, his statement is more or less true, right? So taken as written, we assume that x and y are variables, and n, I suppose, also, right? It's only when you give x and y a value that becomes a number. Okay, but whenever you have a log expression, there's an equivalent way to write it. So I'll just share my screen again, if you're cool with that.
Sure.
Alrighty, so I'll go here into a new cell. Maybe you want to type at the same time, the same thing. So what you basically have is, see, x over sqrt, y. Now you see how those are blue color, the x and the y?
Yes.
That's because I don't have x and y in memory here, right? So hang on, I just have to just remember how the syntax goes. So let's try your log to base 2 of 8 and see if we get. Okay, good. So the syntax is that I need to put e here. And I think that it's actually memory is uppercase E. All right, now it'll just spit it back out when you run that, and that's because the x and the y are treated as variables here, right?
Okay.
They don't have a value yet, but as soon as I give them a value, right? So if I go up this and say x equals 2 and y equals 8, for example, right? Now this is a number. You see, it's log of 2 over 2, or negative log of 2 over 2. Now that's taken to mean to base e, the base for the logarithm. So that's the natural logarithm there. But now if I just go clear all x comma y, and do that again underneath, it'll display that again, right? Log of x over square root of y. Now this is equivalent to, and so at this point I'll make a comment, right? So this is in comment form. So this equals n is, well, let's just say the same as e to the power of n. So e to the power of n is equal to x over the square root of y, right? So these are two equivalent expressions.
Yes, yes.
Now, when this is in, round bracket asterisk, and then you end it with that. So if I run this, that doesn't go through the computer when you do that. So it's an actual comment. You can just type. So yeah. So does that make sense?
Yes. I just want to ask you. You use a semicolon. Yep. Why do you use that for?
Okay. So if I take it off, right? Let's show. Right. So you see, you get a 2 and an 8.
Yeah.
So it hides the output. It just all it does, it hides the output. Yeah. So now those are gone. In fact, we could put it on everything.
Yeah.
And you don't get any output for running the shift and enter.
Yeah.
So yeah, basically when you don't want to display something, you can just put a semicolon after it. Yeah. So you pick up a lot of skills with me. Not only about mathematics, but about programming.
Thanks.
So yeah, I don't know what you're after.
Yeah.
Now the last thing you've written here is 2.718 to the power of n equals this. So that's an approximation, you realize, right?
Yeah, that's an approximation. Yeah, I should have put 3 dots. Or
Yeah. So if you put dots, then you're exactly right. Yep.
Yep.
All right. What can we do for you now?
I just want to talk about your
stuff?
screen.
Yeah.
Output 566. What I would do in this situation, there's got like an accounting form. That's like a command, and it will change that into a number. Do you use accounting form or do you use capital N? Because
what's accounting form?
because I was trying to see what the limit of I was just trying to see the natural log of x if I was going to put x very close to 0, like maybe 0.1. I wanted to know what the value of y would be, and it doesn't really show. So when I put the answer, what Mathematica outputs, when I put that and I put it into the accounting form,
okay,
it shows all the decimal
by accounting
places.
form, do you mean decimal number when you say accounting form?
Yeah. But that's
okay, right. I come from Mathematica.
That's a command in Mathematica that I've used.
All right. Okay. So I'm a little bit confused, but you have to help me out. But for example, in this, so let's just give this a name. I'll call it Z, right? And now if I just go NZ, this would be, I guess, what you would call accounting form, right?
Yeah.
Yeah.
Yeah. I'll bring it up.
Do that. Okay.
I'll bring it up when I find it.
So here we've got the decimal number for this one. So you're probably going to share with me, are you?
Yeah, I intend to. Yeah.
Okay. Sure. How's the weather in Sydney?
Today it's it's not showing. 1 minute. No. It's 21 degrees at the moment.
21 degrees. That's perfect.
Looks very nice in Brisbane.
Yeah, it's a little bit humid lately, but it's okay. It's not too bad. Are you looking for something on your computer?
Yes, I am. Yes.
Okay, sure.
Just show you something else while I find it, though. Then.
Okay.
So this is what I want to show you. One of the questions, like you said, in economics is like we want to find the total revenue. So total revenue, is equal to price times quantity here. So
okay, remember that one.
So if we are given a demand curve, the demand curve is P equals 10 minus 2Q here.
Yep.
And total revenue equals P times Q. So what I did is I used this P and put it here.
Yep.
10 minus 2Q and then times Q.
Uh-huh.
And then I wanted to multiply it out. So I used the expand command. Or I don't know, what would you call this?
Yeah, you've expanded it. Yeah.
Yeah.
So that's exactly right. You've expanded it. Uh-huh. Yeah, perfect. Looks good.
So I'm just checking if I'm doing it inefficiently, or maybe you got some better ideas, basically.
Oh, mate, that looks perfect. I mean, you probably want to visualize that as well.
Yeah.
So basically, you might want to plot the total revenue, and I can see you've done that. Okay.
Yeah.
So now this other curve, the line, that must be like, what's that one?
That's the total cost.
So you're quadratic there. Okay, cost.
Yeah. So
are those meant to meet? So that's break even then, is it?
Yeah. So these when it intersects, that's the break even. That's when total revenue equals total cost.
Yeah, and I guess what you want to do, probably you want to find those 2 points algebraically as well. Is that what you're interested in? Yeah, okay, so I'll show you how to do that. So, do you mind if I share screen? Hang on, I got to write it down.
Okay.
Equals 4 plus, is it 4 plus Q? Okay,
yeah.
Sure, got it. All right, I'll share screen with you.
Sure.
All right, so basically, so you've got 10 minus 2Q times Q, and then essentially you set that equal to 4 plus Q, right? Because those geometric curves intersect when the two are equal, when they've got the same height. So now you could solve this with the computer. So you could just write solve, and you're solving for Q in this case. And it gives you two solutions there, right? These are basically on the x-axis, these are your Q values, these at which you break even, right? But of course you could also do that by hand, and I'll just show you.
Yeah.
So if you had something like, for example, you worked out the total revenue is equal to this, and then let's call it total cost, I guess, equal to 4 plus Q. All right, so what you're doing is you're just saying something like when TR is equal to total cost, then what you have is the two of these are equal, right? This is equal to 4 plus Q. Okay, and now you want to do some algebraic rearranging of this. So you expanded that left-hand side and you got 10Q minus 2Q squared for that. But now if you take the right-hand side over to the left, then you have minus 4 and minus Q equals 0. Right? So you want to express it as equals 0 so that you can use your quadratic formula on that. So the next step now is to simplify. So simplifying this, well, you just collect like terms basically, right? So you've got minus 2 squared, and then you've got 10Q minus a 1Q, so that's plus 9Q, and then you've got minus 4 is equal to 0. Now it's nice if you make the leading coefficient positive, so you could multiply throughout by minus 1. Right, and so let's do that. So minus and then plus. And then you've got to solve this, right? So you could seek to factorize, or you could just use the formula.
Sure.
Do you remember the quadratic formula?
Yeah, x equals minus b plus or minus
that's right.
b squared minus 4ac over 2a.
Oh, there we go. So we've got minus 9, and then you've got plus or minus the square root. Whoops, q rt b squared. So that's minus 9 squared minus 4 times a, which is 2, times c, which is 4. And then that's all over your 2a, right?
Yeah. Okay.
All right, this 2 times 2. But notice how I put the brackets in because I'm dividing here.
Yeah.
All right. So now what we'll do is we'll just, all of this, I'm just typing. It comes out quite bright when you do that, but you don't want to execute it as is, right?
Sure.
So at this point, you turn this into a comment. And then we'll take the q equals off of this as well. And we'll just evaluate that. So because I've got plus or minus, right? So here's the plus, and then the minus case is this. So basically, that's all the working out just to get these two q values there.
Yeah.
All right, and so it's typically this is how I'll do it when I'm writing in this. Yeah, and so I'm going to show you another trick. I'll save this. I typically save these so I can give it to you. Put your name here, and then I'll put 02 11 20. So I'll save that, but then I'll also go and press save as, and then I'll open this. So you see how this, and then I'll find the PDF.
Yeah.
So PDF.
Okay.
And I'll press save. So that's probably coming up on my desktop. Takes a little bit of time.
Okay.
I'll minimize this now, and then I'll just find this. And so this is it as a PDF, right? I don't know if that's useful to you.
Yeah. Yeah, it is.
But you can see like everything we did at the PDF, and then because a lot of people, they don't have it on their system, right? So it's easy for them to see it as a PDF.
Yeah.
So it's also helpful to write things up for assignments and such.
Thank you.
So yeah.
See here, I have a function.
Oh yeah.
And then I put 9 over 4 to evaluate it.
Yeah.
But sometimes I want to put I want to test a few more numbers in. How would I do that instead of copying it all the time and writing it? Like maybe I want to put a 2 or 3 in there. How would I do that?
Okay. So that's basically what happens when we put 0 in, right? So okay, I'll recreate this here and then I'll show you. It's 9 over 4. Yeah. Are you still there, Socheat, or did your mic?
Yeah, I'm here. Yes, sorry.
Cool, that's right. Okay, so can you see my screen?
Yes, I can. Yes.
All right, so let's open this, copy and paste this into another window. All right, and so what we're going to do here is we're going to call this F, and then I'll go F Q underscore colon equals.
Yeah.
Is that right?
Yeah, that looks right. Yeah, I've seen that before.
Yeah, but I can see it's red, so I think I'd need to do this. Okay, so that would put it in memory, and then now I can just go F9 over 4. There we go. Okay, so I'll put this in the chat for you, and you can try that.
Oh, thank you very much. That's what I needed.
So now you can just change your, you can put F of 2 in, for example, and you get 6, and so on and so on. And I think you should even be able to plot by plotting F of Q, for example.
Yeah. Yeah, thank you. I just want to
yeah.
I just want to explain the accounting form, and I think
Okay,
this is probably the last lesson. So I'll just share my screen now.
sure.
Yeah, this is what I wanted to do before. I wanted to.
Oh, all right, okay.
I wanted to do the exponential. See, I'll just start from the beginning, maybe. I wanted to test out this sort of like this function here, and when I plug in 0, it will give me 5. When I plug in 1, it will give me 18.237. 10,
Yeah.
it will give me 78.80, and 20, it will give me 95.
Yeah.
That was the function.
Yeah.
This is some other things I mixed up, but
That's okay. But I'm just understanding what you have in terms of accounting form.
yeah.
So yeah, Mathematica, when it talks about really small numbers, it typically displays that in scientific form.
Yeah.
And so that's just some decimal number times 10 to the power of some small number, right?
Yeah.
But when you put accounting form like you got, it displays it as a decimal number, which is a lot nicer to look at, right?
Yeah.
Most of the time, because you want to use it in something. So yeah, now I understand it. So it's a built-in function, right?
Yeah,
that's maybe why I hadn't heard of it before, because I've never used it.
Yeah.
But yeah, that looks like a good one.
Yeah. So I just wanted to because I've seen you use the capital N function. That's what does that do?
Well, it's similar to accounting form, but so if you have, say, 1/2, and you write N, capital N, square bracket 1/2, in the square bracket, and then press the button, it will give you 0.5, right?
Sure.
So a lot of times when you're doing calculations, Mathematica will stick to the recipe of the number. And by that I mean if it's involving square root of 2, for example, or e or something like that, it'll return that to you in terms of the square root of 2 or e or 1/2 and so on.
Yeah.
Right. Like when you say solve a quadratic equation, it will return that to you as the answer in square root form, right? Without evaluating that numerically. Whereas if you put capital N around it, it'll display that to you as a decimal number, right?
Yes.
And you can take as much precision as you like from the original recipe of the number.
Yeah.
So yeah, but accounting form is slightly different in that it changes scientific notation into, well, something more usable.
Yeah. Thank you.
All right.
Probably for another time. What I want to do is I want to know. I want to draw some tangents here, like maybe at -2 and -4.
Okay.
Maybe that will be a question for another time, or.
Well, I can show you right now if you like.
Okay.
I don't think it will take very long.
Okay.
So,
I'll just stop sharing that.
a tangent would take a first derivative, right? Okay, you're saying something in the chat room. Yeah, there you go, -5 to 3. So I'll do what you had there. Okay, so a tangent would take a first derivative. Now you can do this with the computer.
Yeah.
With the function here, right? So this would be a first derivative, right? And so it just gives that to you as -2 to the -x times log 2, right? Now calculating that derivative of this involves changing 2 into base e, right? So basically, I mean, probably shouldn't be a lesson of calculus right now, but unless you're after that.
Yeah, that's fine.
But what we can do here, so this would be the slope of your line, right? Now it's a function of x, but what you want here is, the line would be, and so I'll write this in comment form here. So y equals mx plus c. This is what you're looking at, where the m is this derivative here, that's the minus 2 to the power minus x times log 2. Right, so I'll just copy and paste that in. So where was this one? Copy from here. All right, so it's that. Now I'm going to change the x into uppercase x and this y into an uppercase x. Why? Because I want to emphasize that it's not the same x and y as on your blue curve.
Yes.
Right? Because they don't have the same x and y values. So that's why I change it to a different case. All right, so now that we've got the slope, next what you want to do is fix a point. In other words, you need to get the value of c. Okay, so let's see, you need to fix a point to get that. Now, when, I guess you can take that from this, right? So in other words, you have y equals, this is the equation for the curve, all right? And so the points on this coincide with the points on this, right? So basically, so let's say these curves intersect when y equals y, basically, right? And x equals x. So what we do here is we can just equate these. We take this and this. And since x equals x, I can change this one into a lowercase x. And that was meant to be an uppercase one there. And then c is the result of solving this, right?
Yeah.
So let's see, you put in particular value. Hang on. I should probably think a little bit more about this geometrically. Okay. That value of c depends on x, where x is the point of intersection of the particular x point. So what I really need to do here is turn this into a particular point, right? Put that everywhere and that everywhere. Where, let's just say, x0 and y0 is the tangent point. The point where those two meet. All right, so then I can take this expression and simplify that, because now we have the value of c if we just rearrange this. So basically, take this over to the other side, and we have the value of c. And then I'll just write c equals that there. Okay, and then I copy that and put it here. So basically, this is this should be the expression for the line, the tangent line, right? In terms of x and y, where x0 is something you presumably have and supply in once you know where you want to take that tangent point. So it's probably a little bit more involved than you were hoping for, right? Now, if we just choose one, so I'll see if I can plot the two of these together now. All right. So what I'm going to do here is take the original one, and I'll say replace all. Take this, and I'll say replace x with, let's go -1. All right, so I'll get a number for that, and now that number is 2. All right, so this here, so this is basically saying, if I have this is equal to -1 and 2, right, as my point that I'm taking a tangent of, then, and I'll make this into a comment there. So basically, then I'm going to find a very particular one for you. So I'm going to replace all the x zeros by -1, and I'll just do that manually. So we got another one there, and another one there. Okay, I'll turn that into a comment. I'll simplify the right-hand side. By doing this. So this is what we've got here. Right, so this is the equation for your line. So in other words, make it part of this. Tangent line y equal to this one. Okay, so in other words, at the point, this one, we have this tangent line. Okay, so now that we have the description of the line, hang on, should be a line, right? All right, I see. This should be the x value as well. So that's, in other words, that's just a 2. Because that depends on x there.
Yeah.
So now if I plot the two of those together, they should line up at that point. So I'll just try this. In other words, I'll back up here and I'll include that. Now in this place, I've got to change that back to a lowercase x so that I can show the two of those together. All right, so here we've got it. It seems to work. Now, they intersect at the unique point when x is -1 and y is 2. Can you see that there?
Yes, I can. Thank you.
All right, so that's it. But I mean, I probably poorly explained this along the way.
Yeah.
In the
That's
example.
right.
And so what I'm missing here, let's see. So I took the derivative. Yeah, this should be basically x subscript 0 there, right? Where that x0 is the particular point. Now this is the description of the line, right? And if we even, so I can call this A and then call B equals list plot. So we had what, -1 and 2. And then we want to show the two of those together. So now you actually see the point itself with it.
Oh, thank you. Yeah, that looks good.
Right. So yeah, I mean, we can go into more detail on that if you still have questions,
Yeah.
if and when we meet again.